Hey everyone, welcome to my channel. In this video, we are going to learn how to detect ArUco markers using OpenCV and Python. So here you can see that I have an example where we are detecting different ArUco markers and we are also detecting their orientation and we are augmenting our specific images on it. So let me show you an example. If I move it around, you can see that it overlays these images. And you can see that even if they are very small, they are still being detected. So if I zoom in, you can see that it still works. So these are just markers. So if we go up here, so this is one example. So the idea is very simple. So let me give you a simple demo here. So right now I have all the markers that I want to detect in one folder. And if I remove these images from this folder, then it will not get detected. So let's run it again. And right now you can see that the mango is being detected. But if I go down, you can see only that one is being overlaid. The rest of them are being detected, but the only one that is overlaid is number 23. So we only have 23 here. And now if I just bring a few of them back, you will see that they will be augmented again. So that's how simple it is. So if I wanted to add more images, for example, 20, 30, 50, even 100 images, I can simply drag them in my folder and they will be overlaid on the corresponding IDs. So ArUco markers, they have very specific IDs that you can generate. So for example, if we look at an online generator, so here you can see that there are different types of ArUco markers. So we can select which is the size that we want. So here you can see you have 4x4, 5x5, 6x6, 7x7. So we are using 6x6. And then you can type in the ID number that you want. For example, 23, or you can write 98. So these are the ones that we are using. And you can also give in the marker size. So here you can see this is 250 right now. You can write 100 as well. So these are different sizes that you can use. So this is our basic idea, and we are going to follow basically this guideline that is provided in the documentation of OpenCV. So detection of ArUco markers. Now this is in C++, but we are going to use it in Python. So we will use this page, and I highly recommend that you go through this page, you read all this documentation. It is very useful, and we are going to use this as an example, and then we are going to learn how to create this ArUco marker detector, and then we are going to convert it into a module so that we don't have to write the code again and again if we want to use it in a different project. So we will be able to use it without writing a lot of code. We will just write a few lines and we will be able to augment even up to 100 to 100 images at the same time. So let's see how that works. And without further ado, let's get started. So here we are in our ArUco module tutorial. So we will first create a new project. I have called it ArUco Marker Tutorial. And then we will go to File and Settings. And by the way, this is PyCharm. If you're not familiar with it, this is one of the best Python IDEs that you can use. So then we will go to Python interpreter and we will add our OpenCV library. But there is a twist here. We do not want to use OpenCV Python. So we are used to using this. We are used to using OpenCV Python, but in this case, we are going to use the contrib Python. So this has the ArUco marker functionality. So we are going to use this instead. So we will install that and it will automatically install NumPy for us. And that should be good to go. So let me increase the size of the font so that it is a little bit easier to read. Okay, so right now we are going to start off with importing. So we will first import CV2, and then we will import CV2.ArUco, and then we are going to import it as ArUco. Then we are going to import NumPy, import NumPy as NP, and then we are going to import OS. So OS will be to find out all these markers, and then we will take them one by one and augment them using their IDs. So the image name is basically the ID. So you cannot just write any name, it has to be that ID. And we will see how we can do that. So the first thing will be that if we are creating a module, then we have to write if name is equals to _ main, then we are going to write that we want to run the main function. So what is the main function? We will define it here. So we have the main function here, and we will simply define our camera. So we will write here cap is equals to cv2.video capture, and then we are going to write the ID number. So I have multiple cameras, so I will write 1, but you should write 0. Most probably 0 will work for you. After that, we are going to write our while loop. So we will write while true. We are going to check for our success, and we will get our image from the cap.read. So this will give us that, and then we can simply show it, cv2.imShow. We will write, let's say, image, and then we will give in our image. So what else? Oh yeah, so we will write also the wait key as 1, so that we give it a delay of 1 millisecond. So by the looks of it, we should be able to get an image. So let's run this and see if it works. So there you go. So I have my webcam right up in front of my laptop screen, and right now you can see the flickering, and this is because of the screen. Actually, let me show you. So this is basically my laptop here, and maybe I should put it back a little bit. Anyways, it should be fine. So hopefully it will not flicker too much. Okay. So what I will do is I will scroll back and forth for the testing part, and we will see how it works. So this is our first ID, and as you can see from the documentation, it tells us this is ID number 23. So here you can see it says ID 23. So we are going to test with ID number 23 first. So let's close this. So now we are going to create the function that is going to find the ArUco markers for us. So we are going to go up, and here we are going to write find ArUco markers, and we are going to send in our image on which we want to find, and then we have to define the marker size. So let me bring up the generator. So as you can see here, we have the 6 by 6, and then we have the total number of possibilities. So we have 6 by 6 and 250 possibilities. So this is the one we are going to use. So here we are going to write marker size is equals to 6. So this will be by default. And of course you can change it as well. So total markers is equals to 250. So this will be the total number of markers available. And then we will also have a flag for drawing. So if we put this true, then it will draw. Otherwise it will not draw all of them. So that should be good. And one more thing is that this size 6 basically means 6 by 6. So we don't have to define it again and again, so we can just write it once. So the first thing we have to do is to change our image to grayscale. So I'm going to write here image gray is equals to cv2.cvt color, And then we have to give in our source image, and then we give in the conversion, which will be, what is it? Color underscore BGR to gray. There you go. So this is the one that we will use. So then we are going to define which dictionary to get for our marker. So basically we are defining to our detector that this is the format that you should look for. So we have to define that 6x6 format with 256 possibilities. So we need to do that, and what we will do is we will create a key and we will call it get. Actually, okay, let me show you the correct way to do it and the simple way to do it, and then I will show you why we are not doing that. So we are going to write ArUco dictionary, ArUco dot dictionary get, and then we are going to write ArUco dot we will have dictionary of 6x6 and 250. So this is basically the idea. But the thing is, this is by default. How can we change this value? Now this is not a string that we can change. So what can we do? What we can do is we can use the get attribute. Basically, it allows you to get the method by using a string. It might sound a little bit weird, but let me show you. So what we are doing is we are splitting these two parts, and then we are using this as a string and using this as a value. So here I can write this here, and then I can write this part here, right? So now I can convert this into a string. So I can write it like this. And now instead of this 6x6 value, I can put in this actual variable. So I can write it like this. And then I can write the total number of markers over here. Okay, so this will give us the exact same thing, not this thing, actually till here. It's basically getting this method, but by using these variables instead of these fixed values. So this is what we are doing. And what we will do next is we will, let's say, call it key, and we can put this key inside here. So that will give us the same effect. So now this is dynamic. So based on our input parameters, we can change the size. So that's good. And then we have to create our parameters. So we will write here that ArUco, let's say parameters is equals to ArUco dot what was it, detector parameters create. Okay, so we will create that, and now we are all set up to detect our ArUco markers. So all we have to do is we have to write in ArUco dot detect markers. We will send in our image gray, and then we are going to give in our dictionary, ArUco dictionary, and then we are going to send it our parameters. So parameters is equals to ArUco parameters. So this is basically our idea. And what this will return us is our bounding boxes. And then it will also return us our IDs. And then it will also return us the rejected IDs. Not the IDs, the rejected markers. So it couldn't find an ID for it, but it found it as a marker. So it doesn't know what that is. So it will just put it in rejected. And it will be like a bounding box. So we can write here rejected. So we can write rejected. Oh, okay, we can keep it like that. So it's going out of the page. So let's bring it down. Okay, so that should be good. And what we can do is now, once we have all of these, we can actually print the IDs, or we can also draw them on our webcam or the image, whatever you want to call it. So let's just print it out first. So we are going to print out all the IDs and let's see what result do we get. So let me copy this till here. So we will paste it right here. And we don't have to worry about all of this because these are default values. And then we can return. Are we returning anything? Not yet. Okay, we will not write it yet. We will just run it. Let's see. So right now you can see it's giving us 23. And if I scroll down, we will have multiple. And now you can see it is giving us the result of multiple IDs. So let me just put it in the center. There you go. So now it's giving us all these different IDs. If I go down, we have one more. So you can see it is giving us the IDs. So it's actually detecting only 4. Maybe because I need to make it a little bit smaller. So these are the IDs it has detected. Okay, so the next thing we can do is we can draw it. So we can write here if draw. So if you remember, we had this flag. So if that is true, then only we are going to draw. So ArUco already has a function to draw. So we are going to write draw marker. Draw detected markers. And then we are going to give in our image that we want to draw on. And then we are going to give in our bounding boxes. And that's how simple it is. So right now it is by default true. So it should draw all the bounding boxes. And there you go. So now you can see we have 4 values and we have 4 bounding boxes that are being detected. And one interesting thing to note here is that this is showing the first corner. So this means it is upright, but this image is rotated. So you can see that the starting point is here. But if it is upright, it should be here. So this is the starting point. So these 3 are fine. This one is rotated. So if I move this around, you can see more of them are being detected as I scroll. And there you go. Even on the small image. And what about the big one? There you go. So it's detecting on the big one as well. So that is good to go. And okay, let me just move it around and you can see how good that is. So it stays on it. So this is on my laptop, and imagine if it's printed, it will be much sharper. So it will be much better in terms of detection. So that is good. If you like the video so far, give it a thumbs up and don't forget to subscribe. So now we need to return these values. So what exactly were we looking for? We were looking for the bounding boxes and the IDs. So we are going to return that. And here in find contours, we can simply call it the, let's say, ArUco found. So the first element will be the bounding boxes and the second element will be all the IDs. So we can use that to our advantage, and we can use that for augmentation. So this is the basic idea, and we can remove this because soon enough it will get annoying. So we will just comment it in case we need it again. So that is good. Now the second part is to augment our ArUco markers. So here we are going to write the function to augment. So we are going to write here ArUco augment image, or should we name it something else? Let's call it ArUco, or let's call it augment ArUco. Yeah. Then here we will be needing the bounding box, and then here we will also need the ID, and we will need the image that we want to draw on and the image that we want to augment. So the images that we have here, for example, this one. So this will be image augment. And again, we have the option to draw the ID. So do we want to display the ID right next to when the image is detected or when we are augmenting? So we can have the flag for that. We can call it draw ID is equals to true by default. There you go. So let's go down a little bit. And here we are going to start off, or let's go down here. Now the thing is that in ArUco Found, we are finding lots of different, ArUco markers. But what we want to do is we want to augment them one by one. So what we will do first is we will take one image and we will augment it on all of them. But then later on, we will learn how to augment different images on different markers. So to do that, we have to loop through our images or our markers that we have detected. So first of all, we need to check, did we detect anything or not? So let's write here loop through all the markers and augments each one. Augment each one. Okay, so here we have to first check if the length of our ArUco Found. Now we cannot check the length of this directly because it will always have a length because there are two lists inside of it. So we cannot do that. Instead, what we will do is we will check the first one. So the first list. If that first list is empty, then it means we didn't detect anything. So we will check here if it is 0, then if it's not 0, then we are going to loop through our boxes. So we will write here bounding box, and we also need to loop through the IDs. So we will write them side by side. And how can we loop them together? By using zip. So we are going to write zip. And we will write here ArUco Found at 0 and then ArUco Found at 1. So this will allow us to loop through both of them at the same time. So that should be good. And then, okay, let's do one thing. Let's just print to see if we are on the right track. So we can print the bounding box. And let's see if we get all of them. So what did we do wrong? Okay, so we cannot leave it open. So let's go up and there you go. So right now we are getting the bounding box. So if we go down, we will get multiple bounding boxes. So let's try with the IDs. So let's write here ID. And there you go. Now we are getting all these multiple IDs. And if we go up, we should only get one ID, which is 23. So that is good. So next thing, what we will do is we will augment our ArUco marker. Finally, we are going to put our image on it. So we will write here image is equals to augments. What did we write the name of it? Augment ArUco. So we will write here augment ArUco, and then we have the bounding box, and then we have the ID. We have the original image that we want to overlay it on, and then we have the image that we want to overlay with. So here we are going to write image aug. So let's open that up. And right now you can see it says image aug is not defined because we didn't import anything. So what we can do here is that we can write image aug is equals to cv2.imread, and we can give it a random one. Let's say markers at 23.jpg. So that is now satisfied. So when it will come here, whatever the case is, it will augment all the images to that with the ID of 23. So it will overlay everything with this image, which is mango. And later on we can write which will augment all these different images with these different markers. So what exactly do we need to do now? Now we know that we have the 4 corner points. We need to, you can say, unpack them. So we can write here that our top left is equals to bounding box at 0, 0, and 0. And then our bounding box at 0, 0, and 1. So we will copy this. And here we are going to write top right. And then we will write bottom right. And then we will write bottom left. So these will be our points. And here we are going to make the changes. So we will write here 1, 2, and 3. And then we will write the same here 1, 2, and 3. So this basically gives us the 4 corner points. Now, if you want to, you can actually use the circle method to actually try each one of them one by one to see which point is which if you are confused. But we are not going to do that because I have already tested which one of these is bottom right, bottom left, and top right and top left. So next we are going to get the size of our image. So the size of the image that we want to augment. So this image, 23 image. So we are going to get the size of that. So we will write here that the height and then the width and then the channels are equals to image augmentation dot shape. So that will give us the size of it. And now what we have to do is we have to warp our image onto the original image, right? So what we have to do is we have to find the homography. And then once we find the homography, that will give us a matrix. The matrix that will allow us to transform from one image to another image. So this will give us the ability to overlay our image in the correct position onto our destination image. So how can we do this? We can do this by creating points. So if you're not familiar with word perspective, I highly recommend that you go and check out my OpenCV course or just the word perspective part so that you understand what we are doing here. Otherwise, it might be a little bit confusing. So here we are going to write our points 1. So our points 1 are basically numpy.array. And inside that array, we are simply going to give in our values. So we have top left, then we have top right, and then we have bottom right and bottom left. So these are our points 1. And then for points 2, we have numpy.float, float 32. And then we have to give in our parameters. Now, again, this might be a little bit confusing, but if you go and check out my word perspective tutorial, it will be easier. So basically, we are telling that in our image, what is this point? So top left should be 0, 0, right? So we will write here 0, 0. Then we have top right. Top right should be width and 0. Then we have bottom right. So bottom right should be width and height. So that is the diagonal point. And then bottom left should be 0 and height. So we write here 0 and height. So that is the idea. Hopefully I didn't miss any brackets. It doesn't seem so. Okay, so we have the points 1 and points 2. So now we need the matrix that will help us in our word perspective. So we can write here matrix, and the second parameter we don't really care about. So we are going to write here that cv2.find homography, and then we have to give in our points 2 and then points 1. Now, once we have that matrix, we can do the warping of the image. So image out is equals to cv2.warp perspective, and then we have to give in our augmentation image, and then we have to give in our matrix, and then we have to give in the size. So the size will be our image dot shape, and the shape at 1, and then the same thing at 0. So this is the width, and then this is the height. Any brackets missing? Doesn't seem so. So yeah, so let's just print this out so you can see what exactly are we talking about. So what we will do is we will return the image out, and did we call this function? Yes, we did. So we will call this back, or the output of this will be image, so it will automatically display us that. So let's see how that runs. So there you go. So now it is overlaying, and you can see that when I scroll down, this is basically our, where it is, this is basically our image out. So if I move my camera, so you can see if I move it around, it actually warps it in the right position. So I will do some extreme actions so you can see. There you go. So if I go really right, you can see it is warping the image, and it is not warping it on the original image. It is creating kind of a new image with all the background as black, and then only the part where we need to warp, it is warping it and creating that image for us. So this is not so bad. We are very close to actually getting our final image. So all we have to do now is we have to create an image with the original image, but with the part where we have the marker removed. So wherever we have the marker, we have to put it as black, so we can use the one that we created right now, which is image out, to overlay with it. Again, it might be a little bit confusing, but within a second, you will know what I'm talking about. So we will write here, fill convex poly. We will give in our image because we want to create it on our image. And then we have the points. The points were 1 or 2. It was 1. And we have to make sure that these are integer. So we will convert all of these into integer. And at the end of the day, we have our color. So the color should be black. So we can put it as 0, 0, 0. And then we have the, what else do we have? I think that should be enough. Let's try it. And yeah, so we don't need to do anything. Let's try it out. Okay, now we need to okay, we are doing it on the original image, so let's not return anything, and let's remove this. So now it will show you what I mean. There you go. So now we have the actual image, but with the parts where we have the marker, the image is removed, it is completely black. So this is what this means. So we are basically filling our original image at the points, these are the points, where we have the marker with complete black. So this is basically the idea. Now we can take this image where we have the black hole and this image where we have only the region where we have the warped image, and we can combine them. And the good thing is that we can simply write image out is equals to image plus image out. And now we can return our image out and we can get the output here. So let's run this and see what happens. If you like the video so far, give it a thumbs up and don't forget to subscribe. Okay, so there you go. So now if I move it around, you can see it attaches there. And as I told you before, it will take that single image and it will overlay it on all the markers. So this is what we are doing right now. Because in theory, we are basically, actually let me just show you here a little bit more and then I will explain further. So let me just move it around so you can see the detection type. It's quite good. And again, because I am using a screen, the detection is not great. But if you use a printed paper, it will be really good. Okay, so what was I saying? Let me go back. Okay, what was I saying? Actually, I forgot. Image out. Yeah. So I was saying that we are going through all of these boxes and all of these markers, and then we are overlaying the same image on all of them, because image augmentation is just this one being augmented every time. So what we can do is, actually, before we go there, we can draw the ID number. We can write here, or let's put it down. Here we can write if draw ID. This is the flag that we gave if we want to show the IDs of the markers. So let's put that. And here we are going to write cv2.putText and we will put it on our original image. And we are going to, actually not the original image now, we'll put it on the image out. And then we will convert it into string, our ID. This is why we added this ID. And what else do we need? We need the points. So we need the origin points. We will give it top left. And then we need the font, cv2.font. Let's just pick the first one. And then we can give in some parameters like the scale and the color. So the color, I'm going to choose purple, 2550255. And then I'm going to give in the thickness of 2. So there you go. And did I miss anything? Hopefully not. Let's try it out. There you go. So now it's showing it is ID number 23. If we go down, it is showing ID 203, 23, ID 62, ID 124, 98. So as you can see, each of these are separate IDs and they are being detected properly. So that is pretty good. Okay, so let's move ahead and let's continue with the images. So now we need to change all our images. So how can we do that? So to do that, what we will do is we will make it a little more generic so that it is easy for us to just drag in and drop our images, and it will automatically do all the calculation and processing for us. So we don't have to rewrite the code to make some changes. So how can we do that? So we will create a new function here. We will call it, let's say, load augmented images. And we need to give in a path. So this path will be of our folder here for the markers, right? So then we will go down and we are going to write here that my list is equals to os.list directory. Now, what does this do? This basically gives us the complete list of our images. So let me just print it out and you can see. So load augmented images. Let me just copy that. And we will go down. And here, instead of loading this, we are going to load this. So here we are going to, let's not do anything else. Here we are going to write, what is the name? Markers. So we will write here markers. So if I run this, am I printing something other than that? No. Okay, so let's run this. And there you go. So this is what I mean. So here it's giving us this list of images within this folder. If I, let's say, remove a few of them, it will only give me the ones that are remaining in that folder. So what we need to do now is, the first thing is we can print out the total number. So we can write here the length of my list is basically the total number of markers that we have. So we can call it number of markers. And then we can print this out. So we can write here print total, let's say, number of markers detected, and then we can write the number of markers. So if we print that, it will tell us total number of markers detected is equals to 6. So right now we have 6 images. That is good. Then we are going to create a dictionary. So what is a dictionary? A dictionary is basically, the word dictionary comes from the actual dictionary where we have the word and the meaning of it. So in dictionaries, we have keys and values. So our key will be our ID, which is 23, and our value will be the image itself. So we are going to write here, let's say dictionaries is equals to, I don't know why I wrote dictionaries, it should be dictionary. Anyways, let's not go into English. So let's just write here that for image path in my list, so we are going to go through each of these paths that we got, 23.jpg, 40.jpg. So all these will be our paths. So we will go one by one and we will create our key first. So the key will be the value 23. But the problem is right now we have 23.jpg. So we need to split it up and we need to get only 23. How can we do that? We have the OS to do this for us. So we can write os dot path dot split text or split path. I think it's split text, and I will write image path. And what this will do is it will split it into two different portions. It will split it into 23 and then JPG. So what I will do is I will take the first element, and that first element will be the ID 23. For the second one will be 40, for the third one will be 62, and so on. So this way we will remove the .jpg. So this will be our key, but we will also make sure that it is not a string, it is an integer. Our key is an integer. Okay. Then we will have our image augmentation. Image augmentation is equals to cv2.imread, and we will have our path. So here, if you remember, if we go down, this is the path, right? So it should be markers / the name of the image with the .jpg. So markers is basically path. So we will write here, let's call it F, and then we will write here path, and then we have a /, and then we have our image path. So this will give us the exact same string. And then we can loop through them, and one by one it will be stored. And all we have to do now is we have to put it in our dictionary. So we can put it in here and we can call it key. We can call it by key, and then we can write here image aug. So this will store the value. So it will be like this. So for example, the first value, the first key will be 23, and the value will be the image of 23. the second will be 40, and then the image of 40. So this is what our dictionary will be from inside. And then we can return our dictionary. So that is, I think that is good. What else do we need? Okay, so now we will go down and we will load all our images. Where is it? So we will remove this and we will have all the augmented values here, which will have the IDs and the images. And now instead of using the image aug, which is now giving an error because there is no image aug, we will use the image from here based on the ID we are talking about. So based on the ID on which we are at right now. So that will give us aug, and then we will write here integer, making sure that it is an integer, and we will write our ID number. So this is our ID, and based on that it will automatically take that image and it will augment. So unless I'm missing something here, this should work fine. So let's try it out. And there you go. So right now you can see that we have all these different images and they are being overlaid properly. And all we had to do was just drag it in our folder. So let me show you again. Let's say I stop this and I take a few of them out. Let's say I take all of them out except for, come on, 23. And let's run it again. Okay, we are getting an error. What is that error? ID is this. Oh, okay, so I did make a mistake. See, it's too good to be true that it works on the first try. I did make a mistake here. Or here. So basically what we have to do is, right now I'm just writing it based on the ID, but I'm not really checking if it is present in the ID. So we have to check and we have to write if our ID converted into integer is in our dictionary. So whatever the ID is detected, whether it's available or not, so we have to check it in our dictionary. If it is available, then we are going to augment it. So let's run that again. And yep, now it works. So now we have 23. And if we go up, you can see that the others are not being augmented. Only 23 is being augmented. And if I close this, and if I just drag one of them in, let's say the 40, which is Apple, then Apple should come back. So let's go down. There you go. So now Apple is back. And the rest of them are still not there because we didn't add them. So I can add all of them again. And let's run it again. And there you go. So now we are detecting all of them. And again, when I'm going down, you can see the top ones are going away because you have to have the complete marker within the image and it should be clear. So then only it will work properly. Here it is quite good because the image is quite small, but still it is able to detect. So that is pretty good. So this is pretty good as well. Okay, let me move it around and you can see how it performs. So there you go. So I can move it around. I can zoom in, I can zoom out. And to be honest, it's very good. And it is real time, so you don't have any processing issues. There you go. So this way you can see that how easy it is to detect these markers and how easy it is to create new markers. Now, because this is a module, what we can do is we can use this module in a different project as well. So all you have to do is, first of all, you will have to load all the images, then you will find all the markers, and then you will augment based on that. So this is the idea. So this code here, you can think of this as the sample code that is required to run it. Now, the last thing we should do is to document this so that it is easy to remember what we did. So we can put some doc strings here. And the good thing about PyCharm is that it already gives you the option to write. It autofills a few things for you. So here we can write a folder in which all the marker images, let's say, with IDs are stored. Then what are we returning? We are returning the dictionary with keys as the ID and value as the augment image. Augmented or let's just keep it augment. So that should be good. And then for the second one, let's put it here, that our image is basically image in which to find the ArUco markers, and then the marker size, the size of the markers, and then we have the total number of markers, if I can type it properly, that compose the dictionary. And what about draw? Draw is a flag to draw. What exactly are we drawing? Flag to draw the bounding box around markers detected. And what are we returning? We are returning bounding boxes and ID numbers of markers detected. Okay, yeah, that should be good. And augment ArUco. Let's write it here. So the bounding box are basically the four corner points of the box. The ID is the marker ID of the corresponding box used only for display. And then we have the image, the final image on which to draw. And then we have the augment image, the image that will be overlapped on the marker, right? Overlapped, yeah. And then the draw image will be the flag to display the ID of the detected markers. Okay, flav off to display, that's great. And then to return image with, what are we returning? Image out. So we can say image with the augment image overlaid. Augment image overlaid. So that should be good. Do we have anything else? No, I don't think so. Let's run it one more time, just for the sake of it, and there you go. So now you can see that we have this ArUco detector, which detects the ArUco markers quite precisely, and even when they are small, and it shows us the IDs, and you can use any number of IDs that you want, and that should work well. And again, if you are using, let's say, let me actually show you. So let's say my new projects. Okay, so if I'm using the ArUco module, I will say that, let's say, imports ArUco module as ARM. So now I can simply use this sample code. So here is my sample code. I will copy this over here. I do need to copy these as well. And then wherever it says there's an error, all I have to do is I have to write arm.load, then arm.find, and then arm.augment. And the markers, is it outside? Yeah, it should work. Let's run this. And there you go. So now I'm using the module rather than running the module itself. And as you can see, I can just integrate this whole project within like 1 minute. And that is pretty awesome. So this is basically today's tutorial. I hope you have learned something new. If you haven't checked out, do check out my new courses on my website. And always don't forget to subscribe and share this video if you find it useful. And I will see you in the next one.